Okay, good morning, students. This is KJ Misra with the second part of the video, video lecture on the same topic, that is chapter 0 mathematical tools. Okay, I had given you homework to find C3, NC3, NC4, and NC5. Have you done that? Okay. See, if you are whatever answer you are getting, you can write in the comment box, okay, of my YouTube channel. And I will obviously look into it and I will reply you. Don't worry, okay? So that you can come to know instantly that you have got correct or not. Okay? See, I'm going to find it out for you so that you can come to know you have done correctly or not. So, NC3. You remember the formula? Factorial N. Okay? Factorial 3. Factorial N minus 3. Okay. Now see, can we write factorial n as n minus 1, n minus 2, factorial n minus 3? We can write it like this. Obviously, we have discussed in the last video, no? What is factorial 3? See, most of the students make mistake over here. Factorial 3 is what? 3 into 2 into 1. So 3 into 2, 6. 6 into 1, 6. So what we write? 6. Many people write 3 directly. But don't do that mistake, because factorial 3 is not 3. It is 3 into 2 into 1. And 3 into 2 is 6. 6 into 1 is 6. Okay. And here factorial n minus 3 is there. Now we can cancel these two. What we will get? We will get n minus 1, n minus 2 upon 6. Okay. Now suppose you want to find out, just you can match this answer with yours. Okay. Suppose you it is given to you, suppose 10C3. What you will do? How you will get? See, it is 10 minus 1 and 10 minus 2 upon 6. Okay. So 10 minus 1 is 9. 10 minus 2 is how much? 8. Okay. So what we will get? 10 into 9 into 8 upon 6. You can just do like this. 2 4 ja 8. 2 3 ja 6 and 3 3 ja 9. So what you will get? 3 4 ja 12, 12 10 ja 120. Okay. So in this way you can find out the value of anyone using this formula. So you have to remember this formula. 10C3, or you want to find out 100C3, you can find out using this formula. Clear? Okay. This is the formula and this is the application part, where how we will use this. Okay. Now it's time for NC4. So let us find out NC4 now. Written. I'm going to rub this. NC4. Factorial n, factorial 4, factorial n minus 4. Okay. Now what we can write here? We can write n minus 1, n minus 2, okay, n minus 3, and we can write factorial n minus 4. Why I am stopping at n minus 4? Because here n minus 4 is there. So again we can cancel it. What is factorial 4, my dear children? Children used to make mistake here also. They write 4 simply. But it is factorial 4. So factorial 4 is 4 into 3 into 2 into 1. Okay. So 4 into 3 is 12. 12 into 2 is 24. 24 into 1 is 24. Okay. So we will get here 24. And factorial n minus 4. This 2 will cancel out. And we will get what? n minus 1, n minus 2, okay, n minus 3 upon 24. Okay. Suppose it is 4, not 4. Let it be suppose AC4. What will you get? See, from here you can write 8. 8 minus 1 is how much? Into 7. 8 minus 2 is how much? 6. 8 minus 3 is how much? 5. Okay. And here what is there? 24 is there. So 8 3 ja 24. 3 2 ja 6. Now what you got? 7 is there and 2 is there, 5 is 5 2 ja 10, 10 7 ja 70. So what you are going to get? 70. Very easily can calculate. This is the formula and this is the use application, how we will use this, okay, whenever required. Now NC5, I think you have written, okay, so I am going for NC5. NC5. See, it is again n factorial, it is 5 factorial, it is n minus 5 factorial. So what you can write here? Can write n factorial as n, n minus 1, n minus 2, n minus 3, n minus 4 factorial n minus 5. Okay. Here what we are having, factorial 5. What is factorial 5? 5 into 4 into 3 into 2 into 1. This is what? This is 5 into 4 into 3 into 2 into 1. 5 4 ja 20. Okay. 3 2 ja 6. So 20 into 6, 120. 120 into 2, 1 is how much? 120 into 1 is 120 only. So write 120 and factorial n minus 5. This and this will cancel out. So what we will left with? We will left with n, n minus 1, n minus 2, n minus 3, n minus 4 upon 120. Okay, this is the formula. You can match your result. Now how to use this? Suppose you are having 10C5. So what you can write? 10. 10 minus 1 is how much? 9. 10 minus 2 is how much? 8. 10 minus 3 is how much? 7. Okay. 10 minus 4 is how much? 6. That's all. 1, 2, 3, 4, 5 terms. 1, 2, 3, 4, 5 terms. Okay. And what is here? 120. Okay. First you can cancel out 0. What? 12 is left. Okay. 4 2 ja 8. 4 3 ja 12. 3 1 ja 3. 3 3 ja 9. So what you are getting? You are getting here 3 2 ja 6. Okay. 6 6 ja 36. 36 into 7. So what you are getting? 36 into 7. So you can multiply 7 6 ja 42. 4 is carry. Now 7 3 ja 21. 21 plus 4 25. So you get 252. Got it? Very easily you can get it. This is the application part, how you will use this, and that is the formula. That formula you have to remember. Okay. So we have got a at last we have got NC5 also, okay, which I have given homework to you. NC3, NC4 and NC5. Now my children, just pay attention. If suppose we are having like this, children is to make mistake here, okay, but I will tell you, don't worry, so that you will not make a mistake. Suppose you are having NCN, then what will happen? Let's see. In this case, what you will have? Factorial n upon factorial n upon factorial n minus n. Now see, factorial n is factorial n only, factorial n is factorial n only, and this is factorial 0. N minus n is what? 0. And factorial 0 is how much? It is 1. So factorial n, because this is 1, so 1 into n is same, okay? And it will cancel, you will get 1. Now, this is formula very easy to understand and write. But my dear children, when application part comes, so where you will use this? Wherever you get, suppose even 1C1, it is how much? 1. Because n is 1. If it is 2C2, how much you will get? 1. If it is 3C3, you will get 1. You will not use that formula, okay? NC3, no. NCN you will use, because both are same. When both are same, then you will use this formula for any value of n. Suppose it is 5C5, then it is again 1. Suppose it is 100C100, Clear? 4C4, it is 1. 8C8, it is 1. Getting my point? Don't make this mistake like the others, because there is a difference between you and the others. Okay? What is that difference? Your hard work. So we have done this also. Now we can see how we can use this formula. Okay? How we can use this formula? Application part. Suppose you want to find out. See, first we are going to the known things. A plus B whole square. How to do this? See here. What we do first? We write NC0. So instead of n, we'll write 2. Okay. Let me write the first, that skeleton formula. This is the power n is what? NC0 a raised to the power n plus NC1 a raised to the power n minus 1 b plus NC2 a raised to the power n minus 2, okay, b square, and dot dot dot. Okay, we will use the terms till we require. But what we are having? We are having a plus b whole square. Let's see we are going to get your formula or not. We will write 2c0 a raised to the power 2, okay, plus 2c1 a raised to the power 2 minus 1, that is 1, and b will also come over here. And then what we will get? 2c2 a raised to the power 2 minus 2 and b square. So a raised to the power 2 minus 2 is how much? 0. And a raised to the power 0 is how much? 1. So we should not write this, because 1 into b square is b square only, no? So why to write this? Okay. Now you tell me, what is the value of NC0? 1. So 2C0, it is also 1. So 1 into a square is how much? It is a square. Okay. Now, what is NC1? NC1 is 1. Is it 1? Really? NC1 is n. Okay. NC1 is n. So 5C1 is 5. So 2C1 is 2. So what you will get? 2AB. What is NCN? NCN is 1. So 5C5, 1. 10C10, 1. 2C2, 1. 1 into b square is b square. Is this your formula? Yes. If you are going to find it mathematically, you have to do. You have to multiply a plus b into a minus b, a plus b, okay, 2 times, and multiplying, then you will get long result. Then you will just, you have to simplify, and then you will get the result. But here you can get simply. Okay. This was known to you. This was one application. I am going to tell you one more thing. See, suppose you want to find out, this was known to you, but you have never found out a plus b whole square. A plus b whole raised to the power 4. A plus b whole raised to the power 4. This formula is not known to you. Do you remember? No. You can find out here. Like 4c0 a raised to the power 4. 4c1 a cube, because 1 power will decrease, and b is there. Then 4c2 a raised square b square plus 4c3, okay, a b cube plus 4c4, the last term, that is b raised to the power 4. Okay, I kept on decreasing the powers of a and kept on increasing the powers of b, and once the b reaches the maximum power, we will have to stop, because 4c4 has come. Okay, now we need to find out the formula for this. NC0 is how much? It is 1. So 4c0 is also 1. So what you will get? A raised to the power 4. Okay. Now, what is the value of NC1? It is n. 5c1, it is 5. 10c1, it is 10. 4c1, it is 4. So what you will get? Plus 4 a cube b. Okay. Next, what is NC2? Just check it. What is the value of NC2? I think you got NC2 is n minus 1 upon 2. That's what you got. Okay. So here we have got 4c2. So you can place here 4. 4 minus 1 is 3. So 3 into 4. Okay. 3 into 4 is how much? 12. Okay. 12 upon 2 is how much? 6. How much you will get? 6. So you can use that 6 here. 6 a square b square. Okay. Now it is 4c3, that is nc3. What is formula for nc3? You know formula for nc3 is n minus 1, n minus 2. Okay. And here we are having 6. Do you remember? Okay. Now you can put here 4 instead of n. So 4 minus 1 is how much? 3. And then here is 4 minus 2 is 2. That upon 6. So 3 into 6, 3 into 2 is 6. And this 6 will cancel out. You will how much? You will have only 4. Clear? So what you can write here? Plus 4ab cube. Okay? Plus. What is the value of NCN? It is 1. 5c5, it is 1. 10c10, it is 1. 4c4, it is 1. So 1 into b raised to the power 4 is b raised to the power 4. So you got the formula of a plus b whole raised to the power 4. It is a raised to the power 4 plus 4a cube b, okay, plus 6a square b square, okay, plus 4ab cube plus b raised to the power 4. Got it? This is formula. Please note it down. Noted? Okay. So these are the homework questions for you. Okay. You have to note it down as well as you have to solve as homework. Okay. And if you want to check the answer, better you can write the result in the comments and I will tell you if it's correct or not. Okay. Otherwise, in the next video, I will giving the answer of this. Okay. Now see, here you are finding minus. Okay, that I will explain. I think you have written the question. You have written all the questions. Written all the questions. Okay. See, this minus part you may find some difficulty. Okay. So what will happen? See, what was our formula? Let me tell you. Our formula was like this, no? It was a plus b raised to the power n. It was nc0 a raised to the power n plus nc1 a raised to the power n minus 1 b, okay, plus nc2 a raised to the power n minus 2 b square plus nc3 a raised to the power n minus 3 b cube plus nc4 a raised to the power n minus 4 b raised to the power 4 plus dot 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 plus ncn b raised to the power n. This was the okay. Now if it comes like this, a minus b raised to the power n, then what will you do? No problem. Wherever you will in this term you will find the odd powers of b. There what you have to do? There you have to put minus sign, that's all. Because you know it minus b means what? Minus b means b into minus 1. And we know that odd powers of minus 1 is what? Minus 1 only. Because minus 1 square is plus 1. But when you are doing minus 1 cube, it is minus. When you are taking minus 1 raised to the power 4, it is again plus because 4 is even. Minus 1 raised to the power 5, it is again minus 1 because 5 is odd. So what we will do? First term here b is not there. So no problem at all. It will be positive. NC0 a raised to the power n. Here b is there. So minus actually b not b but minus b is there. So it becomes negative. Minus NC1 a raised to the power n minus 1 b. Here b square is there. So no problem. It will remain positive. Okay. Now what about this term? Here b is cube. So we will have negative. Here b is raised to the power 4. So it is positive. Okay, in this way it will go. So wherever you will find the power of b is odd, you have to write minus sign before that. Wherever you will find the power of b is even, then you have to write plus. Okay, that is the only small change you have to do. Clear? Now I think you can do the homework very easily. Okay, so this was for the first part of the binomial theorem. That was for positive index. We call it index. The power we call as index. Okay, I'm going to rub this. I think you have noted this. Okay. Now the second part. Part 2. Part 2 is suppose 1 plus x raised to the power n is there. Okay, where x is a real number. Okay, and n is fraction or negative number or positive number. Okay, anything. It can be fraction, it can be negative number, or it can be positive number. Okay, for any index. We call it for any index, means for any power. Okay. How it is written? 1 plus x raised to the power n is equals to n. Okay. Okay. So if it is 1 plus x raised to the power n, what we get? 1 plus nx plus n into n minus 1 x square by factorial 2. Factorial 2 is how much? 2. Okay. Next one, n minus 1 n minus 2 upon factorial 3. Factorial 3 is how much? 3 into 2 into 1, that is 6 x square. Okay. And the next n minus 1 n minus 2 n minus 3. See, one term has increased and power of x also increased by 1, x cube. Here you will get what? Factorial 4. Factorial 4 is how much? 4 into 3 into 2 into 1. So 4 3 12, 12 2 is 24. 24 1 is 24. In this way, it will keep on going. Okay. Let me tell you one thing. In case of that positive index part 1 we have done, no? Maximum how many terms are possible in that? It is n plus 1 terms. Okay. Because we start from 0, no? And we go from NC1 to NCN. So from NC1 to NCN it is n terms, and NC0 that is one more term. So that's why we have maximum how much? N plus 1 terms. Why I am saying maximum? Because any of the terms may become 0. Okay. So terms may decrease, but maximum it will have how much? N plus 1 terms. Here also see, if n is positive, this n is positive number, not fraction, not negative number, then you will have n plus 1 terms only. But if n is a fraction or negative number, then you will have how many terms? Infinite terms. Infinite terms. Okay. Clear? Okay. Please note down the formula. Then I am going to discuss very important thing with you, which will be applicable in physics. Written? Okay. See, the thing which will be very much applicable, which will be used in physics, that I am going to tell you. The formula which will be used in physics. Actually, we do the approximation in physics. What is there? Not everywhere. Actually, it is the accurate signs. Okay. 1 plus x raised to the power n if we are having. Okay. And n is maybe positive, negative, or fraction. Okay. X is less than 1. Then what will happen? Then you can do one thing. You can write 1 plus x raised to the power n. You know very well what you will get. You will get 1 plus nx plus n into n minus 1 upon 2 x square, and this way it will keep on going. And see, as x is less than 1, obviously it will in point. Suppose it is 0.4. Okay. You will make a square of this. What is the square of 4? It is 60. So you will get how much? 0.16. See, it is decreasing. In next term you will get x cube. Then it will come how much? 0.064. If you are getting x raised to the power 4, then how much it will become? Even lesser. So it will keep on decreasing. So we can neglect the terms having higher powers of x. So what we used to do, we approximately used to write, this is the sign for approximately equal to, okay, 1 plus nx. Okay, getting my point? This approximation we use in physics very. Okay. Now, suppose n is a negative number, then what you will get? Minus n. So you will get 1 minus nx. Okay. If suppose this x is negative and n is positive, 1 minus x raised to the power n, then what you will get? You will get 1 minus nx, because n into x is minus nx. Okay. Suppose both are negative, then what you will get? Just note it down first. Noted? Okay. But this is the condition, remember. You can apply this formula where this x is less than 1. Otherwise, you cannot apply. 1 minus x raised to power minus n. If it is like that, then what you will do? 1 plus nx. Because minus n into minus x is plus x. Okay. So this part is very much utilized in physics. Okay. Where and how, that we will come to know when we will studying the chapter gravitation. Okay. So with this we have finished the binomial theorem part. Okay. Now it is time to start the new one, that is called, okay. Now next is some formulae of mensuration which you have studied. Okay. See, these are the formulas of mensuration. First, you are very much familiar. Circumference of a circle is 2 pi r, or if you are having diameter, then you can write pi d. Area of circle is pi r square, or if you are having diameter, then pi d square by 4. Okay. Surface area of sphere is what? It is 4 pi r square. Okay. If it is half hemisphere is there, then it will be 2 pi r square plus pi r square, that is 3 pi r square. Okay. Now, volume of a sphere, it is 4 by 3 pi r cube. Okay. If it is hemisphere, then it will be 2 by 3 pi r cube. Okay. Surface area of cylinder is 2 pi r in bracket r plus l. This is the total surface area. Okay. Now, curved surface area of cylinder is 2 pi r l. Okay. So these are certain formulas. We are having some more formulas. Okay. Note it down first. Okay. Next, seventh formula is volume of cylinder is pi r square l. What is l? L is the slant height. But this is not, this is cylinder, not in cylinder, it is not slant height. Okay. It is length of the cylinder. Okay. So it is pi r square l. Okay. Curved surface area of cone. Yes. In cone it is slant height. See, actually this is cone. This is its radius r. This is height h. And this length is l. Okay. So this slant length is l. So what is the formula for curved surface area? It is pi r l. What is total surface area of cone? Surface area means total surface area. Obviously it is pi r l into pi r square, area of the base. So you can write in this way, pi r in bracket r plus l. Now volume of cone, it is 1 by 3 pi r square h. Okay, we have to take h, not l in this volume. Volume of cube, it is side cube. Surface area of cube, you know cube has got 6 sides and each side is a square. So what we can write? 6 into side square. Okay. Please note it down. Noted? Okay. Okay. So our next topic is logarithms. I know you are not aware of this logarithms. Okay. Actually earlier, I think 7-8 years back. Okay. It was, or 10 years, maybe more than 10 years back. It was there in the NCRT of class 10 mathematics. Okay. But now it is not appearing in any class in mathematics. But my dear children, the problem is that logarithm has got wide application in chemistry as well as in physics also. So it is not taught to you, but you have to use this. That is the problem the students are facing. Okay. So that's why we study in this chapter. Now see, when children hear about the logarithm, actually a fear factor arises in them. But it is not like that. It's not a new thing. You are very much aware of it. What is it? Let's see. See, you very well know, you can write 10 cube is how much? 1000. Now tell me, what is the base here? It is 10. What is exponent? It is 3. What is your result here? It is 1000. Okay. Now see, base will remain base. Okay. You can write it like this. Log. We write logarithms in short. We write log. And whatever is base, that will remain base. Base we write here. And result we write here. And this exponent is our result. Okay. That means if the base is 10, then what power you will raise this base to get this? What power you have to raise this 10 to get this? 3. So 3 is your logarithm. Okay. So logarithm is not new thing. It is actually new way of presentation. Okay. So nothing to worry. Basically in bases we get 10 and number is there, okay, which is called natural logarithm, okay, and the value of that is denoted by e, okay, small e, and e is equals to something 2.78 like that, okay. So this is the basic of logarithm. Just you can understand and you can write, okay, if you want to write. Okay. In general, suppose you are having no a raised the power n is equals to capital N. Okay. Or rather I am writing here a raised the power, okay, x is equals to capital N. Okay. Now how can I write in terms of log? You can write it log base is a of capital N is equals to x. That is all about log. Okay. Now on the basis of this, just tell me what is the value of this. That means what power you will raise this 3 to get 81? 4. So result is 4. Getting my point? Now what about this? I will not tell, just you tell me. What power you will raise to this 3 to get 27? So 3 into 3 into 3, that is 3 3 is 9, 9 3 is 27. So what is the answer? 3 will be raised by power 3 to get 27. Getting my point? So in this way you can calculate logarithm. But always it's not easy because always you will not get the numbers in like whole numbers, okay. You may get fractions, okay, decimals, okay. Okay. Logarithm is of two types, okay. One we actually generally we use log to the base 10, okay. Another log we use log to the base e. Now you might be wondering what is this e, okay. Before that let me tell you, this we call as natural log and this we call as log to the base 10, okay. Now see, if you have to write these numbers like this, okay, you may miss by chance, by mistake, then there will be problem. So what people decided to write this like log only, okay. If you are writing only log, that means it is, people will understand that it is log to the base 10, okay. You don't have to write 10, clear? And to this what they used to do, they used to write ln. If you are writing ln, that means it is log to the base e. But what is this e? That is, you are still wondering. It is, e is actually a constant, okay. 2.718, okay, long number is there. So approximately you can write e is equals to 2.718, okay. This is a number and the log which is connected with this, that is called natural logarithm. Clear? And you can convert from log to the base e to log to the base 10, okay. There is a conversion factor also, okay. See, conversion factor, suppose you have got ln x, that means log to the base e of x. How can you convert to the log to the base 10? For converting to log to the base 10, you have to multiply how much? 2.303, okay. So if anywhere you have got log to the base e, that is in ln, you can convert to the log to the base 10, that is log, by multiplying it by 2.303, okay. Now you have got certain formulas for logarithm, okay. Okay. So these are certain important formulas. See, I have taken here in general log to the base a. Okay. Actually, this is applicable for all the bases. It may be base 10 or base e. Okay. So that's why I have taken in general a. Suppose you got log to the base a of m into n. Two numbers are there. Okay. So what you can write? You can write log to the base a of m plus log to the base a of n. You can add them. Okay. Separately you can find their log and you can add them. Now, this is called sum formula. This is power formula. See, log to the base a, m raised the power n. If it is power is there, then in logs it's very makes easier. You can multiply this here. N is multiplied here, and you can write log to the base a of m. Okay. So you can find out the values of higher powers of a number very easily using logarithm. Here, log to the base a m by n. It is a difference formula. We can write log to the base a of m minus log to the base a of n. Okay. Now, this is the base changing formula. Suppose, as we have done, no, we have converted from ln to log. That is log to the base e to log to the base 10. How to do that? Suppose you are having log to the base a of m and you want to convert into log to the base b of m. How to convert? First you write log to the base b of m, then in that you have to multiply log to the base a of b. Log to the base a of b. You have to multiply in that value. Then you can change it. That means when we have found out this relation, that is ln x is equals to 2.303 log x. Okay, that means what we have done, it was log to the base e of x equal to log to the base 10 of x multiplying log to the base e of 10. Okay, so that means this is this is this. What is this? Log to the base e of 10 is 2.303. Okay, that is this formula. So you note down this formula. That's all for this video. Okay. Now in the third part of the video, no, please be ready with the log table. You may find in backside of your practical notebook or any other book. Okay, or you may be having some competitive books at the backside. You might have log, okay, natural logarithm. Or you can do one thing. In your mobile, you can just open the site and you can open the formula and take the screenshot of that. Please keep it with you while watching the next video, that is third part of this 0 chapter, that is mathematical tools. Because there I will be teaching you how to see the log table, how to utilize it. And this will be of great use in chemistry as well as in physics. And if you are going for competitions, it is very much required. My dear children, you know very well the calculators are not allowed in board examinations or in the competitive examinations. But my dear children, log table is allowed in the board examination as well as in competitive examination. Oh, you might be thinking, no, who will provide it? You have to ask only. Okay, the authorities will provide you. Okay, so you must know how to use logarithm because it makes calculation easier. And it has got wide application also. Okay, so till the next video, thank you and take care. Just keep on studying. Bye bye.